Yeah, dear learners, welcome once again to Accountancy Mathematics, where we make mathematics easy and fun. So, if you are a high school student who is actually preparing for KCSE, this is a paper that can actually change everything because this is a paper that has been set with the standard of KCSE, especially on the most expected areas and the areas that are highly likely to be examined. Therefore, it's important that you get to follow through keenly and carefully. So you don't have to try to cram anything or to guess anything. What you just need to do is to follow through keenly, and I believe by that you'll be able to increase your confidence in mathematics, to expose yourself on the most examinable areas, and also at the same time be able to shift you from where you are to a place that is a bit higher. And let's get directly into the questions that you have. And for your information, if you wish, you can actually get yourself a pen, a piece of paper, and if possible, a calculator, yeah, so that we can work it out together with you. Let's get to our question one. A very wonderful question, and this is a highly examinable question. Therefore, it's important to understand how you are really supposed to tackle such a question once you find it in your exams. So we have 2 into brackets logarithm of 2.5 base 10 plus logarithm of 40 base 10, all that is divided by 3 logarithm of 0.05 base 10 plus 2 logarithm of 2 base 10 minus logarithm of 0.5 base 10. A very interesting question for our case, and let's just get into it. So when we have such a case, what are we really supposed to do? So the first thing is to check how these numbers are really arranged and how they get to appear in the question, so that we can be able to identify how best we can be able to simplify them and how best we can be able to go about that. So once we check at this, you realize that what we have here is that all the logarithms that we have here, they are all under base 10. Therefore, this makes our work easier. Therefore, we do not have to convert any logarithm to a certain particular base because they are under common base. Then from there, we check here and we try to see the places where we can be able to do some simplification. And to some extent, we can be able to simplify the upper part. That is the part that is inside the brackets. And remember, as we also tackle logarithms, we also try to observe the law of BODMAS because it is constant and gets to apply everywhere. So we start with the brackets first, and we have log something plus log something. And you remember the law that says that when you have got logarithm of a certain number and then it is added to a certain number, that one will always give you logarithm of those number multiplied together. This is what we call the addition multiplication law of indices, and that is what you are going to apply right here. And actually after this, I'll direct you to a place where you can be able to learn everything about logarithm. For now, let's get into this particular question. So once we apply this law, what you're going to get here is 2 into brackets. And here is an important thing to know, that when the base of a logarithm is 10, you can just simply write it without the base because by default, the logarithm is usually to base 10 when it is not indicated. Therefore, for this case, you can go ahead and just write log without indicating that it is to base 10 because automatically it's going to be translated as such. So we have 2 into brackets logarithm of. Now what we do is that we take this number, we multiply by this. Therefore, we have 2.5 multiplied by 40. So that is what we will have for the uppercase for the numerator. Let's go to the denominator and see what we get. So for the denominator, it's quite an interesting case here because we've got a number before the logarithm and also here a number before the logarithm, but even beyond that, we've got a minus. So here is a really combined case which makes this question to be so much interesting and to be so much good for our practice, because you are practicing like 10 things in one question. You see, so doing this question alone is like you've done 10 questions. So let's go ahead and see how we are really supposed to do it. So this is the first law that we have applied. So you'll notice here, whenever you've got a number, suppose that you've got a number A, and then you have got logarithm, and then you've got a number here. This one is always equivalent to the logarithm of that number. I hope that you're really following carefully. And then you pick the number that comes before the log, and then you power it, you place it there. So this is a law of logarithm that we are supposed to apply here. So when you've got this case 3 logarithm of 0.05, this one will be equivalent to the logarithm of 0.05, and then we pick this 3 and we place it here at the power, and then we go ahead with the question. So we'll have it plus 2 logarithm 2. We do the same thing, so we'll have logarithm of 2, and then we pick these 2 and we place it here where we have the power, and then we have a minus. Here we don't have a number appearing before the logarithm, therefore that is going to be retained just as it is, and that is a logarithm of 0.5, like that. Amazing. The question is becoming a bit more interesting. Let's go ahead and see how we are really supposed to solve it beyond that. So here we'll just have to, and what about here? We have logarithm. So we multiply 2.5 times 40. You can try to work out that. That is supposed to give you 40 times 2.5. That is 2.5. 2.5 times 40. That's going to give you 100. This is interesting. And then we divide by, what do we get here? You see, this is an interesting case because you see what you're having here. I'll choose this upper part just to write the formula so that you can be able to easily copy them and try to study them a bit. Whenever you've got a case like log of something and then it is added to something and then it is minused by log something, this one will always be equivalent to logarithm of these two numbers that are here divided by the number that has been subtracted. This is another law of logarithm that we really need to also study and really understand. And let's go ahead and apply it, because the moment that we apply it, the moment it becomes a bit easier. So for this case, what you're going to get is logarithm of, now what we have here, 0.05, and remember it is 2 power 3, and then we multiply. And why do we multiply? It's because the sign that stands in between the logarithms is an addition. So each and every moment that we are having an addition sign in between the logarithm, we usually turn it to a multiplication, but now we factor out the log inside and then we multiply the numbers that are there. So we multiply by 2 to power 2. But what do we have here? We have a minus. Since we have a minus, we have to divide with 0.5, like that. And remember, all this is the denominator, this is the numerator. So let's go ahead and simplify the cases that we have here. So finally, on the upper case, what you're going to get is 2 logarithm of 100, and then we divide by, let's go ahead and do 0.05 to power 3. That is multiplied by 2 to power 2, which is 4, divided by 0.5. Interestingly, this one is going to give you log 1 over 1000. Yeah, because once you do 0.05 to power 3 times 2 squared over 0.5, that is going to give you 1000, which is equivalent to 0.001. So let's go ahead and proceed on with the question. So when you've got such a case like this one, what you try to do is that you'll try to convert this number into a multiple of 10, into 10 to power something. Therefore, this is going to be 2 logarithm. For this case, remember we say that we can write to base 10 or we can leave it like that. There is no harm. So we have 2 logarithm. Because when we have log base 10 and log and just simply logarithm, it's all the same thing, because when you don't write, that implies that it is still under base 10, because that is the fundamental and the default base for logarithm. So we have 2 logarithm and then we have 10 squared. So because 100 is equivalent to 10 squared, 10 squared is 10 times 10, which is 100. And then we have that divided by what we have here is logarithm of this is base 10. You see, say 1 over 1000, we can be able to write it in terms of 10 to power something. You see, this one is equivalent to 10 to power negative 3. 10 to power negative 3 will give you 1 over 1000. So we can write it like that. So this is why I'm telling you that this is a very interesting and a very wonderful question to practice with. So once we have such a case, the next formula that you are going to apply, well, I would have loved to write this formula here, but I want to keep these formulas here so that you can easily revisit them once and once again, even after we are done with covering the whole session, so that you can be able to write them specifically somewhere. So when you've got something like logarithm of a base a, this one will always be equivalent to 1. This is a law of logarithm. So that implies that when you have got something like log 10 base 10, this one will always give you 1. This is a law of logarithm. Very important. And also, another law that you are going to apply here is that when you've got a case like logarithm of m to power n, this one will always give you n logarithm of m. You see, it's kind of like we are actually revisiting all the laws of logarithm just under one question. So that implies that when you've got logarithm of m to power n, it will always be equivalent to n log m. This is what you're going to apply here. Therefore, it's important that you follow through keenly. So what we have here is that we are going to shift these 2 from here to here, such that we are going to get 2 multiplied by 2 logarithm of 10 base 10, and then we divide by, we shift this negative 3 to this location here. You have negative 3. Remember, this is the law that we are applying to do that. So we'll have negative 3, and then we have log 10 base 10 like that. So finally, you see this part here. This is log 10 base 10, and this is log 10 base 10. For this one, there are 2 ways to go about this. For one, you can divide by log 10 base 10, divide by log 10 base 10 to remain with 2 times 2 divided by negative 3. But then alternatively, you can say that log 10 base 10, which is here, is equivalent to 1, which will actually give you the same thing, and that is 2 times 2 divided by negative 3. So eventually this one is going to give you a negative 4 over 3. But you see, interestingly, we've been able to reduce all these numbers to simply negative 4 over 3. But it's quite important that you realize and you get to walk through the formulas that you've gone through, that you've checked through, because the question might come in a way that is a bit different. So this is the first formula that you've checked. This is the second formula that you've applied. This is the third formula. This is the fourth formula that we've applied right there. Therefore, it's important that you get conversant with all these formulas. And actually, the only formula that I feel that we may not have attended to is actually which one? Because actually these are almost all the formulas that we are really supposed to know under indices. Maybe this is the one that we've not checked through directly, and that is when you've got logarithm of a minus log b. This one is always equivalent to the logarithm of a over b, even though we have applied it in a way that is combined in this question over here. But mainly these are the formulas that are usually tested in most of the times. Therefore, it's important that you get acquainted with that. Maybe the other one, though it is not commonly tested, is that when you're finding the log of 1, this one will always give you a 0, like that. So this is also another formula that you can add in your book so that you can be able to revisit over and over again. So with that, let's move on to our second question, a very wonderful, interesting question over here. Actually, this will actually help you to revise on Surds and to help you understand how you are really supposed to go about this kind of questions. These are questions that rarely misses in paper 2 KCSE exams. So we have 2 divided by 2 plus root 5 minus 2 root 5 divided by 2 negative root 5. So you are told simplify that and express your answer in the form of a plus b root c, where a, b, and c are constants. Well, there are two major ways of getting to solve this question, but let me show you the quickest and the easiest way to go about this, which will actually help you to be free from making errors, and that is a bit credible, which will also help you to earn all the marks that have been given out in the question. So what we do is that we pick this number the same way it is, and that is 2 divided by 2 plus root 5. And then what we do is that we rationalize this number. But how do we do that? We find a way of eliminating this root 5. How can we get rid of this root 5? It is simply by making this number to be multiplied by a difference of 2 squares. Let me go ahead and show you how to go about that. So what we usually do, don't be worried about the terms. We usually say we multiply by the discriminant of this, but you don't have to worry about that. The easiest way to understand this is that you usually pick the number that is here the way it is, but you change the sign that is here. If this one was a positive, you simply change it to a negative. If it was a negative, you simply change it to a positive. For our case, this is a positive, therefore we convert it to a minus. Therefore, we are going to multiply by 2 minus root 5, like that, divided by the same thing. And it's important to understand why we are doing this. We are multiplying by 2 minus root 5 divided by 2 minus root 5 because this one is like multiplying by 1. And you see, when you multiply something by 1, it doesn't change the value of that number. Therefore, that implies that we are not changing the value of this number. It is only that we are converting it from one form to the other. So let's go ahead and minus here. So we have minus 2 root 5, and this one is over 2 minus root 5. And this is a very good question, and the reason it's a very good question is because we have different cases here. Therefore, you'll be able to see it on different edges. Therefore, because this one is a negative, therefore we convert it to a positive. Therefore, we are going to write 2 plus root 5 there, divided by 2 plus root 5 there. Let's go ahead and simplify each and every case independently. So we start with this first case over here. So what you'll be doing here is that we're multiplying 2 by every number. Let me help you visualize that. So let me actually write it here for you. So we'll take 2 and then we multiply it by 2 minus root 5. This is the number that is outside, and then this is the number that we have in the brackets. And here, there's a formula that we apply here. That is, whenever you've got a number like a minus b, and then it is multiplied by a plus b, that one is always equivalent to a squared minus b squared. Amazing. So this is what you apply here. So you see this is of the nature a plus b multiplied by a minus b. Therefore, we pick this number, we square, therefore we'll take 2, we square that, and then we minus root 5, and then we square that. Here we've got a minus, and what we have here is 2 root 5. And then we have into brackets 2 plus root 5. Again, just as we have applied this formula here, we will also get to apply it here, such that we are going to have 2 squared minus, now root 5, we square that. Let's go ahead. And this is a part that you're really supposed to be very careful as you handle, because you can easily make a mistake as you open up this bracket. So we have 2 multiplied by 2, that is 4. We have minus 2 multiplied by root 5, that is 2 root 5. Amazing. 2 squared, that is 4. And then we have minus root 5 squared is not 25. This is an error that most people make. Root 5 squared is not 25, but root 5 squared is equivalent to 5. Why? Because this square helps us to get rid of this square root that is there, so that we can remain with 5. Finally, we have minus 2 root 5 times 2. That's going to give me 4 root 5. And then we have, this is an addition sign. Yeah, it is an addition sign. And then we have 2 root 5 multiplied by root 5. 2 root 5 multiplied by root 5. It's important to be able to see this. This is like 2 multiplied by root 5 multiplied by root 5, which is 2 times 5, because root 5 multiplied by root 5 is going to give you a 5. I hope that you do understand that. Root 5 multiplied by root 5 is going to give you a 5. Therefore, you'll have 5 multiplied by 2, which is going to give you a 10. And here, you'll have 4 minus 5, like that. Amazing. So this question is becoming more interesting and much easier. Let's go ahead and now solve this. But actually, this is the part that most people do usually make a mistake, and I'll show you which mistake is that. But for now, let's simplify this upper part. You see here, what you're going to get is 4 minus 2 root 5, but this one is divided by 4 minus 1, that is negative 1. And here we've got a minus sign. And remember, when you've got a minus sign, that minus sign applies for all the numbers that follow, especially if it lies under numbers that have got numerator and denominator. So what you're having here is 4 root 5 plus 10 divided by 4 minus 5, that's negative 1. That's what we are having. So we go ahead and get rid of this negative 1, or rather we just get rid of the denominator. But how do we go about that? We simply divide every number by negative 1. So we have 4 divided by negative 1. That's going to give me a negative 4. Yeah. We have negative 2 root 5. You have to be very careful here. Divided by negative 1, the negative is going to disappear. Because negative divided by negative is a positive. Therefore, we are going to get positive 2 root 5. And then we have got a minus. And notice this minus applies to everything that is in here. Let me open up these brackets for you. And this is a part that you have to be very careful so that you don't make an error. So we have 4 root 5 divided by negative 1. That's going to give you what? It's going to give you negative 4 root 5. And finally, we have 10 divided by negative 1. That's going to give you negative 10. Amazing. This is a bit interesting. So we have negative 4. Nothing much you can do about it for now. And then we have plus 2 root 5. And then here is now the wonderful part of it. We have minus 4 root 5. Therefore, because we have two consecutive minuses, it automatically becomes a positive. And then we have 4 root 5. Same case with here. We have got a minus and then a minus 10. Therefore, that becomes a positive 10 like that. If you don't check out here, you are likely to write negative 10, which is very, very wrong. So let's go ahead and put the like terms together. We can start with 10. So we have 10 minus 4 plus 2 root 5 plus 4 root 5 like that. So we have 10 minus 4, that's going to give us a 6. We have this plus, and then we have 4 plus 2, that's 6 root 5. Let's go back to the question. I'll simplify that and express your answer in the form of A plus B root C. And actually, this is exactly what we've done. And that is the required solution for that question. And that is how you are really supposed to tackle about that. You'll notice that for each and every question that you are tackling, it's helping us to revise in multiple ways using just a single question. Like for now, you've seen how you're supposed to do when you've got a case where we've got a plus here, what you're supposed to do when you've got a case where this is negative, and also what you're really supposed to do when you encounter such a case like this one where you've got a minus and then you've got other numbers. You always remember to put these brackets so that you don't confuse the signs and so that you don't make that mistakes of mixing up the signs. And that is it for question 2. Let's now check out on question 3 and see what the question 3 is really requiring us to do. We are told that a wedding committee did a budget for a wedding ceremony as follows. Oh, these people started with food. Interesting. So food is shillings 58, 205. Chairs is shillings 11,950. Entertainment 804.53. Oh, why add shillings 53 to entertainment? Wow. We never know their plans, but let's go ahead. Our interest is in the question and what the question wants us to do so that we can handle that. So we are told that the sum of the budget was done by first rounding each figure to 3 significant figures, determining the sum of the budget. That is part A. I believe that there will also be part B, but we'll get to that. Or can we first check that? Yeah, let's check to cure your curiosity. Determine the percentage error. Wow, this is such an interesting question because it will help us to check on a number of things which are likely to be examinable. So the first thing that we do is to find is to round off these numbers to 3 significant figures. This is very important, 3 significant figures. So mostly what many students do confuse is 3 significant figures with 3 decimal places, but for to 3 numbers, like there are many students who usually takes like 3 significant figures. It is as if like you're supposed to go from ones, tens, and hundreds. It's kind of like you're supposed to work out this to the nearest hundreds, and that is very wrong. That's not how we find significant figures. The way that we find significant figures is that we start counting the figures from the left hand side as we move towards the right hand side. Therefore, that implies that we'll go to the first number, second number, third number, and this is where we are going to place a line there. And then we check whether this number is more than is equivalent to the immediate number that comes after the line, whether it is equivalent, we need to get rid of that, whether it is equivalent to 5 or more. If it is more or equivalent to 5, we usually add a 1 here and then we put zeros here. But then if this number is not more than 5, what we usually do is that we retain all the numbers as they are, but everything after this mark will automatically become a 0. Let me write it down so that you can be able to understand it well. So for such a case, this is a 0. It's not more or equal to 5. Therefore, what you're going to get here is a 58. And then we have 2. And then this one, we are going to convert it to 0, 0. Therefore, it becomes 0, 0 like that. Let's go ahead and find out on this case. So for this case, we count 1, 2, 3, and we put a small mark over there. So once we have such a case, what do? We check whether this, and actually this is a very interesting one. And this is the reason, because this one is a different case with this one. Because 1, 2, 3, this one is already a 5. Therefore, we must add 1 here. So if we, okay, so when we've got such a number, so what you're going to do is that we are going to convert all this to 0, so such that we'll have 0, 0. But what we do is that we add 1 here. So we add 1 here. So if we had this number, that is 11,950, and we are checking at that term 1, 2, 3. So we convert this one to 0, 0, but we add 1 here because this number is 5 already, and then we find the sum of that. So here we already have 0, 0. So we have 9 plus 1, we get 10, we have 0, we carry 1 to get 2, and 1, 2 over here. So this is going to give us 12,000. So that number becomes 12,000 like that. Let's go ahead and check on this case. So in this case, we have 1, 2, 3. We count 3 numbers from the left-hand side, and we check whether 3 is significant. If 3 is significant, then that's when we should add a 1. But if it's not significant, if this digit is not significant, we just convert it to a 0 and we don't add anything. But for number to be significant, the digit that comes after this line, it should be 5 or more. And since this one is not 5 or more, what you are going to have is that we are simply going to convert this one to be a 0, such that we are going to have 8,450 like that. So we have 3 significant figures, this one, and this one. 0 becomes insignificant like that. So let's go ahead and see what the question is telling us to do. So the question is telling us determine the sum of the budget. So the sum of the budget becomes then 58,200. We have 12,000, and we have 8,400. I believe we can be able to work out this because this is 0, 0. We have 4 plus 2, that's 6. We have 8 plus 8, 16 plus 2, 18. 8, 16, 18, yeah. 8, we carry 1. 5, 6, 7. 78,600. So that becomes the sum of the budget. The sum of the budget becomes shillings. 78,600. That's quite interesting. So let's go ahead and see the second part of the question. So the second part of the question is telling us determine the percentage error in this sum of the budget, So we have to understand how are we really supposed to calculate the percentage error. And this is quite a good question. Percentage error. So to be able to get the percentage error, so what we do is that we calculate the difference between the actual budget and the budget where we have three significant figures, and then we divide by the actual one multiplied by 100. Let's go ahead and put it into writing. So what we do is that we can pick any of them, whichever will be the largest. But as we do that, we can first calculate the actual budget and see what that is likely to give us. So let's work out the actual budget first. So to be able to get the actual budget, what we are going to do is that we add these figures here. We can actually add them directly with our calculator so that we can be able to be a bit more faster. 58,205, we add that to 11,950, and then we add that to 84. That's 84,53. That's gonna give us 78. Yeah, 78,608. 78,608. That's what we get because it is 58,205, 1109, 50, 84, 53. It's always good to confirm that you really added it correctly. So percentage error will be now what we have here, the difference between the two divided by the actual multiplied by 100. So what's the difference between the two? We get the difference by doing 78,608, and then we minus what we have here, which is 78,600 divided by the actual. Remember, the actual budget is now the budget that we have here without rounding the figures to very significant figures. Therefore, the actual one, we'll take it as 78,608. 78,608, like that. And then finally, we are going to multiply that by 100. Let's go ahead and simplify that. So what we are having here is this figure that we have 78,608 minus 78,600. That's gonna give you 8 divided by 78,608, and then we multiply that by 100. So this is something that you can be able to work out quickly, yeah, with your calculator. So that we have 8 divided by 78,608, and then we multiply that by 100 and see what you are going to get. So that is going to give us a 0.01012%. So you can always leave it at that, or you can leave it to 3 decimal places, that is 0.010. Yeah, whichever case that you leave it with, especially if it is not specified in the question, it will be accepted, and that will be very correct. So with this, the most important part that I would emphasize on is how to get the percentage error, which you've been able to find right here, and also how to find, or rather to convert numbers to certain given significant figures. So that is what the question was really testing about. So let's get to our question 4, a very interesting and wonderful question also for our practice, and also a question that really gets to appear a lot in KCSE paper 2. Therefore, it's important that we get to walk through it here together and do so very keenly. So we have 4 sine x squared plus 4 cos x is equals to 5. And then we are told solve that equation for x is greater or equal to 0, but less or equal to 360 degrees. Let's go ahead and try to solve this. So this question is really testing on this particular concept, and that is whether you know that sine 2x plus cos 2x is equivalent to 1. Because you see here, we've got quite combined cases. We've got a sine and also we've got a cos, and it's not possible to work with them when they are like this. Therefore, we have to find a way of either converting cos into sine, or we convert this sine into cos. But you see, it is very hard for us at this level to convert the cos to sine. Therefore, the easiest way to go about that is to find a way of converting this sine into a cos, and that is where we get to apply this formula. Therefore, we can make sine x squared to be the subject of the formula by taking cos x squared to the other side, such that you are going to have sine x squared is equivalent to 1 minus cos x squared, like that. Yeah, you remember that whenever a certain number, letter, variable crosses the equal sign, it must change the sign to a minus. And that is exactly what we have here. So we are going to substitute sine x squared with this sine x squared here. And actually, this is the format that you use for all the questions that appears like this, such that you are going to have 4 into brackets. Now, instead of writing this sine x squared, we are going to write an equivalent of that, which is 1 minus cos x squared, like that. And then we have plus 4 cos x is equals to 5. So let's go ahead and open up the brackets. We have 4 multiplied by 1, that's gonna give you a 4. We have a minus 4 multiplied by cos x squared, that's gonna give you 4 cos x squared. And then we have a plus 4 cos x is equals to 5. Well, I would love to make this 4 cos x squared to be a positive, and the only way to do that is to take it to the other side. So let's take up everything that we have on the left side to the right side, such that you are going to have 4 cos x squared. So once we take it to the other side, the negative sign disappears. For this case, once we take it to the right side, it becomes a minus 4 cos x. I'll tell you why this is important. And then this 5 remains the same because it is still in the initial position where it was. 4, when it crosses the other side, it becomes a minus 4. And then what will be left with on the other side will just be a 0, because we've taken everything away from it. So we can go ahead and try to simplify this. Would it be possible to do that? Yeah, it's possible. So we have 4 cos x squared, we have minus 4 cos x, and then here we have 5 minus 4, that's gonna give us a plus 1 is equals to 0. So what we have here is such a wonderful equation, because now we have everything in terms of cos and cos, but we don't know what the value of cos is. Therefore, we can let the value of cos x to be y. Therefore, we are going to let it to be y, such that this one is cos x squared. Therefore, that is going to be equivalent to y squared. But before that, we have a 4 there, and then we have a minus 4. This cos x, we've let it to be y. Therefore, we do the substitution there, and then we have a plus 1 is equals to 0. We are not done yet. However, the question has become a little bit much easier for us because we've been able to form an equation. And if you look at this equation very keenly, you're going to realize that it is a quadratic equation. So how do we go ahead and solve it? So we look for two numbers such that the sum is -4, but the product is 4. We usually take the coefficient of the variable that is squared, which is 4, we multiply by the number that is here, which is 4 minus 1 to get 4. Now that will be the product of our numbers, and the sum usually take it as the middle number that is right here. So we look for two numbers such that the sum is -4 and the product is 4. What are those two numbers? Yeah, you can take a second to think about that. Yeah, but I hope that you'll definitely get -2 and -2. So those are the terms that you're going to expand the middle term with, such that we are going to have 4y squared. Now instead of writing -4y, we are going to use these two terms. Therefore, you are going to have -2y minus 2y plus 1 is equals to 0, like that. So once we have this, we factor out the common term. For our case here, we pair them into twos, then we factor out the common term. For our first case, the common term here is 2y, therefore we factor it out. And then once we factor out 2y, what do we get here? I believe we should get a 2y, and then we have a minus 2y divided by 2y, that's gonna give you a 1. Then we have minus, we factor out here a 1, and inside the brackets you are going to have -2y divided by -1, that's gonna give you 2y, and then we have 1 divided by -1, that's gonna give you -1 is equals to 0. So essentially this one gives you 2y minus 1 multiplied by 2y minus 1 is equivalent to 0. Therefore, that implies that 2y minus 1 is equivalent to 0. You can pick this -1 to the other side to get 2y is equals to 1. You divide by 2 everywhere, divide by 2, divide by 2, you get that y is equals to a half, like that. But now, that's not yet done. We have to go back to the question and do our working and find out what is the value of y. Our value of y is right here, cos x, this one over here. So we say that cos x is what is equivalent to y. Therefore, cos x, which you don't know, is equivalent to y. And what is y? Y is equals to a half. Therefore, that would imply that x is the anticos of a half. So with that, you can be able to find out that what is the anticos of 0.5. The anticos of 0.5, that's gonna give you 60 degrees. But then again, you see, we are told that x is greater or equal to 0, but less or equal to 360 degrees. Therefore, we have to operate under these constraints. And this now brings us the this circle that you usually use. Usually say that at the first quadrant, we have got the second one, third one, fourth one. So this is the point where we have 0 or 0. This is where we have 90 degrees. This is where we have 80 degrees. This is the place where we have 9, 18 to 70. This is why you have 0 stroke 360 degrees. Therefore, the only place where this cos can be positive is under this first quadrant and in this final quadrant that is there. Therefore, we can be able to find another value such that cos that value will be equivalent to a half. But how do we do that? How we are able to do that is that we take this 360, we minus 60. So we do 360 minus 60. That is going to lie in this quadrant that is right here. So what you're going to get here is 60 degrees, and then 360 minus 60, that's gonna give you 300 degrees. Can we confirm that cos 300 degrees is equivalent to a half? yeah, it should be equivalent to a half. Same case with 60 degrees. And once you are able to get that, you confirm that they lie within 0 to there is 60 degrees, they should be within that range. But if you leave it alone at 60 degrees, well, that is correct, but that is not a full correct answer for that, because you will have left out 300 degrees, which is also an answer for this. Therefore, it's important to follow along all that. But for this question, the most particular thing that was really tested is whether you can be able to convert from one particular attribute to the other, like sine to cos or cos to sine, and also whether you can be able to solve a quadratic equation, but also even beyond that, whether you know where all the whether you know where cos is positive, where sine is positive, where tan is positive, yeah, and so on. So it's very important that you get to understand that. So this is circled with the different quadrants to help you be able to know where all the attributes are positive and where they are not positive, so that we can be able to know how to get other angles with just one single angle. I believe that once you get such a question, whichever way it will be twisted, that will be able to really answer that. Let's get into our question 5, a very wonderful and interesting question. So we are told expand 1 minus x to power 4 using the binomial expansion. A very interesting question. So this is 1 mark, but I believe that there could be another second part of it that we get to follow after this. But just before we get into that, let's first get to handle this part 1. So the first thing that you're really supposed to know is to get the binomial coefficients. So I believe that you may have come across the Pascal's triangle that is usually like this one, and then 1, 2, 1. So we usually start with 1, and then we go to 1 to 1. So this is just the Pascal's triangle to help you get the coefficients of expansion. I'm going to show you how we are going to apply that very shortly. For now, let's go ahead and populate these. So normally what we usually do is that we pick this number, we add it with the adjacent number, and then we put the results in between them but below them. So we have 1 plus 2, that's gonna give you a 3, 2 plus 1, that's gonna give you a 3, and then we drop the one that is here, we drop the one that is there. Same case with this one, we add the numbers that are adjacent to each other. 1 plus 3, you get a 4, a 3 and a 3 here, you get a 6, a 3 and a 1, you get a 4, and finally we have this one, we drop it just right there. So this is the binomial expansion for something squared. So this is the binomial expansion for a certain number to power 3, and here is where our interest lies, and that is a number to power 4. But that is not all of it for this. So we should be able to expand this. And normally, if we expand this, what you're going to get is that we are going to get 5 terms. You see, we have got the first term, second, third, fourth, fifth term. So always note that when it's something to power 4, you are going to get 5 terms. When it is something to power 5, you get 6 terms. When it is something to power 10, you get an additional term that will be 11 terms. So for this one, even before you work it out, you already know that it is going to give you 5 terms. So it should be something, let's say like that, 1, 2, 3, 4, 5, like that. And you can always put a multiplication there. Okay, I mean an addition sign rather, an addition sign there, an addition sign there. So I'm trying to use the easiest way to help you understand this. So what you have there is that you have those terms, and then because you're supposed to have them as 5 terms, the next thing that you do is to assign what you have some powers. So you have to assign some powers to this. So for instance, here you start with power 0, therefore you start with 2 power 0, to power 1. And notice we are assigning to the place where we have got this x. So we have 2 power 2, we have 2 power 3, and we have that 2 power 4 like that. 0, 1, 2, 3, 4, 2 power 4 like that. And finally, we also assign this other value here, the powers, but now we start with 2 power 4, 2 power 3, 2 power 2, 2 power 1, and finally 2 power 0 like that. And what else do? We also now multiply with these coefficient values. So here we are going to multiply by 1. All these, it's going to be multiplied by 1. The second one, we multiply by 4. The other one, we multiply by 6. The other one, we multiply by 4. And finally, the other one, we multiply by this one. You see, it becomes a bit easier when you get to arrange your work in such a way that you can be able to follow through, such that we have 1 times 1 to power 4, that is still 1. And then we have negative x to power 0, that should give you a 1. So we have 1 plus. Here we have 4 multiplied by 1 to power 3, that's going to give you a 4, multiplied by negative x, that's going to give you a 4x. So we are done with that part so that you don't repeat yourself. Here we have a 6. 6 multiplied by, so we have a plus here, and then we have a 6. Negative x into brackets, so this is squared, therefore that's going to give you x squared. And then we have a plus sign over there. And then we have 4 multiplied by this. This is negative x to power 3. This is going to give you negative x to power 3. And we have it multiplied by 4. Therefore, that's negative 4x to power 3. And finally, what we have here is a plus. And then we have 1 multiplied by 1 to power 0. 1 to power 0, remember that that one is equivalent to 1. Therefore, this is like 1 times negative x to power 4. You see, when you power this 1 to power 4, the negative sign disappears because this is an even number. Therefore, this one becomes simply a plus x to power 4. We can be able to completely simplify this to have 1 plus minus, that gives us a minus 4x plus 6x squared. We have a plus minus, that's going to give you minus 4x to power 3. And here we have a plus x to power 4. And that becomes your solution. That's how you're supposed to tackle part A. Let's move on to part B. So when you've got any equation, totally any equation that is involving binomial expansion, you should be able to solve it using this procedure that we've used. But I'll be back here to clarify something a bit about that. For now, let's just get ahead with the second part of it. So we are told use the first 3 terms of the expansion in A above to find the value of 0.998 to power 4. How should you really go about that? So you see this one, what we have here, that is 1 minus x, this one, 1 minus x to power 4, 1 minus x. This one is directly compared to this one. And this is what you do for all the questions that revolve around this, 0.998. So you should be able to get the value of x. But how can you be able to find the value of x? You can pick x to the other side to have x is equals to, and then you pick 0.998 to the other side to have 1 minus 0.998, such that we'll have x as equivalent to 1 minus 0.998. You are going to get 0, 0. So we have the 0 points. This is 0, 0, 2. 0, 0, 2. Interesting. You have to be a bit keen as you do this subtraction so that you don't make an error of these zeros. You are likely to write 0.02, which is, 0.02, which will be incorrect. Therefore, you have to be very careful on that. So we already have the value of x. What next do we do now that we have the value of x? We check the equation. It is telling us use the first 3 terms. So we are going to use this first term here. That is one term. The first term. And then we have minus 4x plus 6x squared. These numbers look so amazing. So let's go ahead and try to work out this. So we already have the value of x, therefore we just simply go ahead and substitute. Therefore we have 4 multiplied by x, which is 0.002 plus 6 multiplied by 0.002, and that is squared. So we go ahead and try to simplify this. So this is 1 minus 4 multiplied by this is 0.008 plus, this will be quite a larger number because it is having 0.002 multiplied by itself, that is 0.002, and that is going to give you something to do with 0.00004, and then you multiply that by 6. That is going to give you quite a huge number, which would be something to do with 2.4 times 10 to the power negative 5. But this one you can just write it in the decimal format, which is 0.000024, like that. Finally, you just get to simplify that by now adding 1 and then minus 0.008 to see what you are really going to get. But once you do that, you should be able to get 0.992024. Yes, like that. And then finally, is there anything that you're really supposed to do about this? Yeah, definitely. We go back to the question, which is the guiding principle. We are told, give your answer correct to the nearest hundredth. Oh, so this is tenth and this is hundredth. Therefore, we draw a line there and we check for this number. So we check whether this number is 5 or more. Therefore, since this one is not 5 or more, therefore we just let it out and we just ignore everything. We don't add anything. So what we simply remain with is 0.99, like that. Amazing. And that is how you're really supposed to talk about that. That is how you're really supposed to solve that question. And that is the required solution for that. So I'm really hoping that if you get any question involving binomial expansion, you'll be able to do it. But in case there's a part that you never understood, you can always get back and replay this video later on. But the most important thing is to understand how to work out this binomial expansion. Let's say it was 2 power 5, you could just have come here, you say 1 plus 4, 5, 4 plus 6, 10, 6 plus 4, 10, 4 plus 1, 5, and then you drop these ones there. This would have been the binomial expansion to power 5. But then again here, you start with the power that is here, which is 4. You go to 3, you go to 2, 1, 0, like that. But now for the value of x, you start with 2 power 0 to power 1 as you advance like that. And you remember here what you've done. So that is it for that. Let's move on to another question asking, or rather testing on something that is a bit more different. Wow, and this is really sounding so cool. We are really revising and doing questions that have got high likelihood of being tested. So it's important that you get to understand on how you are really supposed to solve each and every question. So we have P is equals to VW squared over V squared minus W squared. So you are supposed to make W the subject of the formula. So the first thing that we do is to try and locate where it is. Notice here there is a square root like that. So our main aim and our main goal is to isolate W as much as possible, to remove everything that is here until we remain with the W alone. So what we do here, the first thing that we do is that we square each and every side like that. We square each and every side like that, so that we can first get rid of this square root that is here. Therefore, we are going to remain with p squared is equivalent to vw squared, and then that is divided by v squared minus w squared like that. This sounds so amazing and interesting because it's becoming a bit more better. So with this, we can do some cross multiplication like that. And let's do the cross multiplication and see what we are going to get. So once you do the cross multiplication, what you're going to get is p squared into brackets v squared minus w squared, and then that one is equivalent to this value that is right here, which is vw squared. Amazing. Let's go ahead and try to open up the brackets. We have p squared multiplied by v squared, it will be like that, then minus p squared w squared is equals to vw squared, like that. So what do we do next? We have got a w here and a w here. So the next thing that we try to do is that we try to put these terms together. Therefore, we are going to take all these terms to the other side, such that we are going to remain this side with v w squared like that. But when this crosses the other line, it must become a positive. So we get a positive p squared w squared is equivalent to, now we are going to remain with this figure alone, with this set of numbers alone, that is p squared. Oh, this is quite bad that this has been taken away to the other side, but we really have to do it so that we are able to get the value of w. So the next thing that we do is that we factor out the components of w. So we have w squared, we factor it out. What we remain with here is a v, and then we've got a plus. What we remain with here is a p squared, like that, is equivalent to p squared v squared, like that. So finally, we can pick this v plus p squared to the other side and see what we get. So what we are going to remain with here is w squared, and then on the other side we are going to get p squared, v squared, all that is divided by v plus p squared. Amazing. At least we've been able to put a w squared aside, and finally what remains is simply to find the square root on each and every side, because our main goal was to find a representation of w squared. So we are going to remain on the left side with w, and then on the right side we remember that when you find the square root of something at this level, you should be able to get it as positive or minus that value, and then we have got a big square root, p squared v squared, all that is divided by v plus p squared. And that is exactly how you are really supposed to tackle that question. Yeah, but the most important part was how you can be able to isolate a number and put it aside, like the way that you are able to isolate this w squared, put it aside, and finally to be able to end up with it. And also, there is also another important element that was being tested over here, whether you know that the square root of a number is always equivalent to plus or minus that number. Therefore, it's important to be able to understand that and to be able to work out that. Amazing. Here it's another important question. We are actually almost revising each and every topic that is there, because now we've not gotten to revise a bit on trigonometry, but here is a wonderful question that is going to help us in this. So we have y is equals to 3 sine a half x plus 60 degrees. So we are told, given that that equation is like that, we are told find amplitude, period, and the phase angle of the function. How are we really supposed to find that? You see, this one, it is in the form of A is equals to, or rather, let me put it in the simplest terms, in a way that you'll always be able to hack this out. So this is in the form of A, or rather y is equals to A sine, and then we have into brackets, and then in those brackets we have something. Let's assume that this one will always be bx. So I want to give you a formula that will always work. Regardless of the question that you get here, you can always be able to get it correct by just getting to master what I'm about to tell you. So this is what you really need to master. You just need to master that whenever you've got such an equation like this one, the value that is here, which is A, that one should always be the amplitude. Amplitude. So you don't need to really sweat a lot or to really worry about such a question. And you see, it is asking us about the period. Let me show you the easiest way to get that. So to be able to get the period, always take the 360 and then you divide by this coefficient of x. For our case, for our formula, it is b. You just divide by that. You should always be able to get such a question like this once you get it, by just getting to apply this formula. So the phase angle, the way that you are able to get the phase angle is that you pick the value that is here, that is C, and then you divide it by the value that is here. For our case, the value that is right here is a B. So you divide it by B, but you remember to put a negative sign here. Therefore, you change the sign that is there. So if you can be able to master this, then you should always be able to get any question that is asking about amplitude, period, and phase angle. So when you'll meet such a question, you'll not start like shaking or sweating or anything, because you already have a formula that will always work out for you. But now let's get to our question that we have here. We have 3 sine I have x. Let's apply this practically so that you can see how you are really supposed to apply it practically. We've said that the amplitude is equivalent to A, this part here, 3. So you just write 3. And then you just go to the second part. You say, oh, they are asking you to find the period. You just write period. You say it is equivalent to 360 divided by b. So you say 360 divided by b. So you compare these two. Where does b lie? What's the coefficient of x? It is simply a half. So you just simply divide by half. What is 360 divided by a half? And actually, you are likely to make a mistake here if you are not careful, because you are likely to say that 360 divided by a half, that is 180. I don't know if that is what was in your mind, but that is totally incorrect. Because you see, 360 divided by 2, that is what is going to give you 180. But 360 divided by half, that's going to give you 720 degrees, like that. And finally, we check out the third part. How are we supposed to get the phase angle? The phase angle, we said it is negative. Start with the negative so that you don't forget. And then C over B. What's the figure that lies here? It is 60. What about B? B is right here, which is a half. We divide by half. So this is going to give you negative because of this negative. And then you have 60 divided by half. That's going to give you 120 degrees, like that. And that is exactly how you're really supposed to solve about that. And that is the correct solution for that. So what I want to leave you with is that formula that you can always apply all the time, and always be sure that you'll always get it correctly, regardless of the type of the equation. So let's move ahead and see. Oh, amazing. Here we've got a really an interesting question. We are told that ship sails due north from a latitude of 20 degrees south for a distance of 40 nautical miles, and then it goes ahead and tells us find the latitude of the point it reaches. Yeah, very interesting question for our practice. So what this question really wants to test is whether you know how to convert nautical miles into degrees and also the other way around. So let's go ahead and check it out. So we are told that the distance that these ships gets to travel is 1440 nautical miles. So we are really supposed to know how many degrees is equals to these 1440 nautical miles. And the unit of conversion that we are going to use for that is that 1 degree is equivalent to 60 nautical miles. Then we ask ourselves, what about 1440 nautical miles? So what you do is cross multiplication like that. Therefore, that will be equivalent to 1440 nautical miles divided by 60 nautical miles. This is 1440 times 1. It doesn't change so much. So we have 1440 divided by 60. What do we get by that? We can go ahead and do 1440 divided by 60. That's going to give us 24 degrees like that. But you're told this ship was on 20 degrees south. So we are having 20 degrees south, which we are adding to this 24 degrees. So the first thing that you're really supposed to know is that we already have the ship was already below the equator like that. So it was below the equator with how many degrees? With 20 degrees like that. So this ship was there. Therefore, once you add 24 degrees, if it rises 24 degrees, therefore that implies it will have to cover these 20 degrees first, and then it then covers another 4 degrees upwards, so that now it will be on 4 degrees north. Therefore, that implies that 20 degrees south plus 24 degrees towards the north, that should give you 4 degrees. You need to write the word degrees well so that it doesn't appear like it's 40, and it's important to clarify that you really need to really write it well. Therefore, what you get is 4 degrees, but that is towards the north. And that is exactly how you are really supposed to go about that question. But the most important thing here is to know how to convert the distance from nautical miles to degrees so that you can be able to solve from there. So therefore, this is an important formula. If you wish, you can note it somewhere. You might need it later on. Oh, haha. So we have got this very juicy and wonderful question. Equation of a circle. Amazing. So we are told that the equation of a circle is given by 3x squared plus 3y squared plus 3x plus 42y plus 30 is equals to 0. And then the question goes ahead and tells us determine the radius and the coordinates of the center of the circle. Let's go ahead and solve it. But from what I see, well, this question will turn out to be something that is a bit interesting. 3x squared plus 3y squared plus 3x plus 42y. I don't know why I get a lot of people saying that they have got challenges with solving equations of a circle, but that should come to an end from this particular part once you solve it. So once we look at these, you will notice that all these numbers are divisible by 3. Why don't we simplify our life and make it easier by simplifying these numbers so that you don't deal with large numbers where we can be able to deal with lesser numbers. So let's divide by 3 everywhere. So here we get x squared plus divide by 3, you get y squared, plus divide by 3 here, you get an x, plus 42 divide by 3, 4 by 3, 1, 3 by 12. Is it 4? You need to confirm that, because if you make any error at this stage, then it's going to be really costly. Plus 30 by 3, that's gonna give you a 10 is equals to 0. That's very good and very important. So you'll notice that you've gotten such a more simpler equation, and that is how it's really supposed to be. So with these, what we'll try to do is that we'll try to put the terms that are a bit common together, like we've got an x and x, y and y. We try to put them together, and then from there, I'll show you an interesting way to solve this. So x squared plus x plus y squared, and then plus 14y. On the other side, we can pick negative 10. It doesn't have a partner yet, but we are going to give it one very soon. So once we have this, what we do is that we complete these squares. You see, this is x squared plus x. So to complete this square, what we usually do is that we take the coefficient of x. Let's be careful on this. We take the coefficient of x, which is 1, we add it here. So we are going to have plus 1, but we divide it by 2, and then we square that. I hope that you do notice that, and you've been able to understand that we're taking the coefficient of x divided by 2, and then we square that. And then we go ahead with what we have, that is y squared plus 14y. So what we are adding is the coefficient of y now divided by 2. That would be 14. We divide by 2, and then we square that. And remember, whatever you do to one kid, you also do that to the other kids. Since we added here 1 over 2, which is squared, we also add that to the other side. Therefore, this will be plus. Actually, we can go ahead and simplify a half squared. That's gonna give you 1 over 4. Also, we add what we've added here. This is 14 divided by 2, that's 7. 7 squared, that's gonna give you 49, like that. Amazing. This becomes a bit more interesting. You realize that this one is a perfect square, and also this one is a perfect square. So if we are to factorize this, what we are really supposed to get is this value, which is x, and then added to this value, which is a half, and then that squared. I'll show you how that is so. So we have a plus. If you factorize this, actually, if you wish, you can take up the longer process, but you really need not do that, because there is already a simpler method to factorize this. So you get a y, which is here, plus now this 7 squared is equals to. So here's the interesting part. You see, if you open up this, you will get this equation. So this equation is similar to this one. How do you open this equation? We usually take the first case, we square it to get x squared, and then we multiply everything 2 by x by a half. That's gonna give you an x, and then we square the last element, which is a half squared. Same case with this one. We usually square this to get y squared, and then we multiply everything 2 times y, which is 2y, times 7, which is 14y, and then we square this part, which is 7 squared, and 14 over 2 is equivalent to 7 squared. So what we are doing here is just some factorizing. Finally, we get to this case. What is negative 10 plus 1 over 4 plus 49? So 49 minus 10, that should give you 39. But what about 39 plus 1 over 4? What do you get from that? 39 plus 1 over 4 is 157 over 4. like that. Amazing. The question is a bit becoming much interesting and actually much easier, because now the final part that remains for us is to know how the equation of a circle looks like. So an equation of a circle looks like this: x minus a squared plus y minus b squared is equals to r squared. This is the standard form of the equation of a circle. So we go ahead and find, we already have x directly like that, y like that. Now what remains for us is to find the value of a. Therefore, say that a is equivalent to what? This part that is here. The way it is, that is a plus a half. You see, this one is negative a. Therefore, negative a is equivalent to a half. Then that would imply that a is equivalent to negative a half. This is very important. We pick, you see, this is like y minus b. Let me actually take the whole of it so that you can be able to understand it better in a way that it will never give you trouble ever again. So this is y minus b. It is directly connected to y plus 7. So if you are to subtract y, you remain with negative b is equals to 7, which then would imply that b is equals to negative 7. Notice what we do here is just multiply by negative 1, multiply by negative 1 to remain with b is equals to negative 7. So this is the value for a, and also we have here the value for b. But now the center of the circle is equivalent to now AB. And what is AB? AB is negative a half, negative 7, and that's the center of the circle. Does the question require us to find anything else here? The center of the circle and the radius. You see, this one is directly connected to the radius. Therefore, radius squared is equal to 157 over 4. Therefore, to get the radius, we find the square root, there. Therefore, r for radius is equals to the square root of that. Let's find out the square root for that. So once we find the square root for this, this is going to give us 6.26498. That's quite huge. We can convert it to two decimal places to have 6.26 like that. And you write units because it has not been specified whether we are dealing with centimeters, meters, kilometers. But I don't know. Do we have some circles that are kilometers of radius? Well, there could be. Yeah, but we just leave it as that, like units. Let's move on to the next question. This is question 10. Oh, amazing. So we are supposed to draw a straight line MN such that MN is equal to 7 centimeters. This seems to be part A of something. Therefore, that implies that there is part 2 and 3. Ah, great, great, great. Well, how are we really going to construct this? So we'll get back to this question later, or maybe let me do this. I'll get to guide you on how you can be able to do that. Since I had not assembled the tools, that is the protractor, the ruler, and the compass and all that, I'll guide you exactly step by step on how you'll be able to do that. And actually, it's important that you try it on your own. So to be able to draw a straight line, MN, such that MN is 7 centimeters, what you're really supposed to do is that you're supposed to take up your ruler and you put it in a horizontal way like that, and then you measure 7 centimeters. You start with from where the 0 mark is. You see, if you start from where the 1 mark is, you are likely to measure lesser units. Therefore, to measure, we start from where the 0 units is, and then you draw a very straight line like that until where the 7 centimeter mark is exactly there, and then you say that that line is MN. This is something that you can be able to do. The second part is construct the locus P. When many people hear the word locus, their minds tends to turn away because it seems to be something hard, but locus is actually one of the easiest topics that you can be able to handle. Let's go ahead and see this. It's telling us, which is quite interesting, construct the locus P such that MPN is equals to 90 degrees. MPN is equals to 90 degrees. How do you construct such a locus? So one thing that you're really supposed to know, and this is actually testing on the properties of angle properties. You remember when you said that in angle properties that when you've got something like this, let's say like you have a circle, and then that circle, you have it like there, and you have a line that is passing via the radius, then this line which is passing via the center of the circle, which we call the diameter, that diameter will always make 90 degrees with the circumference. If you draw a line there, this one will be 90. If you draw a line here like that, this one will be 90. Whatever place that you draw, provided that that line is coming from the diameter, it will always make a 90 degrees. Therefore, that is the concept that you are going to apply here. So the real deal and the real goal here is to measure, or rather to construct a circular part that is revolving around this, such that the middle of this part will be now our radius, or rather passing via the center. So we are going to establish the center. If this line was 7 centimeter, therefore the center should be 3.5 centimeters from M and also 3.5 centimeters from N. Therefore, what you are going to do is that you are going to take your compass and then you measure 3.5 centimeters from here to this part here. Therefore, this part should be 3.5 centimeters like that. And also on this other part, it will be 3.5 centimeters like that. Therefore, you are going to take your compass like that and like that, and then you use it and you revolve it around here using this one as the center. You turn it like this such that you're able to draw a circle. So you draw like half a circle like this, yeah, such that it gets to pass by that point, and also you also draw another part like that, such that it passes like that. But this one is just a sketch. You'll be able to do that very well when you've got the compass. So this one is what you are going to name as, what do you call it? Construct the locus P. This is locus P. That's P. Because anything that is connected to here, if this line is connected here like that, this is going to give you 90 degrees. If this angle runs from here to here, then this angle is going to be 90 degrees. So that is it for that part. The final part, and here you're just getting some free marks. On the locus P in A above, mark T such that T is equidistant of M and N. M and N. So we need to find a point that is equidistant from this point to this point. How should we do that? So what you do is that you'll come, pick your compass, extend it, mark this, and let this be the place where the one arm stands, and then the other arm you extend it up to a point like this, at least some bit such that it passes beyond the center a little bit like there. And then you put like a mark there. You put a mark upwards, and also you put another mark downwards like that. Similar case with the same equal of length, you come here and you let it this to be your standing point for one side, the sharp side of the compass, and then you make an arc, and also you make an arc, and finally you are going to join those two arcs like that. And once you join those two arcs, then this one, this is point T. This, you are going to say that this one is now point T. Therefore, this point from anywhere, if you pick this point from here, it will always be of equal distance from here to here. No matter where it is, if it's here, it's going to be equal distance from here to here because it is passing via the center of that circle, and that is exactly the point T. So this is point T, and this is the locus of P, and that is how you are really supposed to handle that. You can try it out later on your own. That is when you'll be having the instruments of work, what we call the compass, the ruler, yeah, and all that you may need for that. But for now, let's get to this very wonderful question. We are told the table below shows the tax table for monthly income, where we have the monthly taxable income in shillings and tax rate in each shillings, and then we are told in a certain month Kamau tax was 33, 36. Determine his income during that month. How are we really supposed to go about that? You'll notice that in this month, the amount that has been taxed is 96.80. What about here? To get the amount that is taxed here, we do 18,800 minus 96.80. Let's follow through keenly. This is quite important. 18,800. We start by doing what we can be able to do so that we can be able to get what is asked. And here is almost 9120. That's the amount that is being taxed. So we are told that in a certain month, Kamau tax was shillings 33.36. This is the tax. Determine his income during that month. So for this amount, how much tax was paid? Let's find out. So for the first part, that is part one. How much is taxed? It is 10% of. And actually, it's important as you do this to know if there's second part of it. No, there's no second part of it. So we'll only use the information that we have. I also will not go beyond that so that we are able to save some time. So we have part 1, 10 over 100, that is 10% of 96.80. What do we get? We have 0, 0, divided by that. So that is shillings 968. Amazing. Part 2. Part 2, the amount that is charged is this one, 9120. Therefore, you are calculating 15% of that. So that's 15% multiplied by 9120. Can you be able to divide by 10? Yes, divide by 10. That's correct. Can you be able to divide by 3? Not really. We divide by 5 here, we get 3. We divide by 5, we get 2. Yeah, you have to be very careful. Divide by 2, 1. Divide by 2. What do we get here? Yeah, 912 divided by 2, that's 456. 456 times 3, that's 1368. Remember that the total tax is 33.36. Therefore, we don't know the amount that has been charged here. So we are going to let the tax for this part to be X, amount X. So the amount that is being charged here is 20%, 20% of X. Therefore, we know that 20% of X plus the tax that he paid for part 1, which is 968, plus the tax that he paid for the third part, which is 1368. Oh, we are having 6868. Is it a coincidence or amazing? So is equals to 36. So 20% x plus, we can be able to add this 968 plus 1368. That's 2336. 2336 is equals to 3336. So we have 336, 336. So simply we can take the whole of this to the other side to have 20% of x is equivalent to, once we minus 3336 minus 2336, that will give us 1000. So that implies that 20 over 100 multiplied by x is equals to 1000. What should we do to remain with the value of x? So we multiply by 100 over 20, multiply by 100 over 20. So what we get here is 20 divided by 20 divided by 10 divided by 100 divided by 100. We get x is equals to shillings. Here 20 by 1, 25. 100 divided by 20, that's 5. And here is 1000. So we get 5000 like that. So this is the amount that was really taxed here. So finally, what are we really supposed to do? Finally, we are supposed to get the total. We are supposed to determine his income during that month. So the income, that one we are going to get it from 9680. We add 9120 and we add 5000. What do we get? 0, 0, 6, 7, 8. What is 18? 18 plus 3? That's 23. Yeah, 23. So that one will be equivalent to shillings 23,800. And that is the required solution for that. And I believe that you've been able to follow through that. Oh, amazing. Here is another interesting question for paper 2, commonly asked. We are told that in the figure below, OC is the tangent to the circle. OC, where is OC? OC, it's right here. This is the tangent to the circle. If OE from here to here is 8 centimeters, and OC is from here to here is 6 centimeters, find EA. So we are supposed to find the unit from here to here, which we do not know. EA. So one thing that you're really supposed to know is that the distance from here to here, and this is a formula, therefore you can apply it anywhere and everywhere for a question that looks like this. The distance from here to here, OE, multiplied by the distance from here to here, which is EA, will always be equivalent to the distance from here to here, which is OC, but squared, like that. So what remains for us, since we've been able to identify the formula, is to go ahead and substitute the values that we have. OE is 8 centimeters. We multiply by EA. What is EA? EA, we don't have it, is equals to OC. OC squared, that is 6 squared. So we have 8 EA is equivalent to 36. So we divide by 8, we divide by 8. We get EA, because divide by 8, that is 1. We remain with EA is equals to 36 divided by 8. That is going to give you 4.5 centimeters. And that is the required solution for that Oh, amazing. We've not yet dealt with differentiation and integration, but I believe this is a good question to deal with to be able to revise on that topic. Let's go ahead and check it. We have it as follows. We are supposed to, we are told that the integration of 3x squared plus 1 dx in respect to dx from 4 to 1. This is what we are supposed to find. That is the integral of 3x squared plus 1 in respect to x. So what should we do? To find the integration of these, what we usually do is that we usually pick that number the way it is 3x squared. So we usually add 1 to that number, and then we divide by the result of the power. That is 2 plus 1. And then we have got a plus here. And then you see here we've got a 1. What is the integration of 1? When it is just a number, or rather what we usually call a constant, what we usually do is that we always multiply that by x if it is in respect to x. Therefore, the integration of 1 will be x. Therefore, we simply write an x there. And then we put some brackets there to indicate that this one is from 4 to 1. But before we can get to replace these values, we can simplify this a bit. We have 3x cubed is equal over 3 plus x. This is 4 to 1. This one can be simplified further by dividing by 3 to get x to power 3 plus x. This is 4 to 1. So simply what we get from this is that we get to put this 4 inside, we substitute by 4 to get 4 to power 3 plus 4, and then we put a minus. We now substitute 1 inside. Where we have an x, we put a 1. So here we get a 1 to power 3 plus 1, like that. So 4 to power 3, so we get to work out that 4 to power 3, that's gonna give you 64. Therefore, we write 64 plus a 4 there. And then we have a minus 1 plus 1, that's gonna give us a 2. So finally we have 68 minus 2, that's gonna give you 8 minus 2, that's 6, and we have a preceding 6 there. So finally you get 66, and that is the required solution for that. But here is the most important thing to understand, and that is whenever you are having any number, let's say it is y to power n, and you are finding the integration of that, what we usually do is that we usually take that number the same way it is, and then we add 1, and then we divide by the results on the power, which is n plus 1. So for this part, this is the formula that you are really supposed to really understand, that is how to do the integration. But for differentiation, if you have got a case like, let's actually pick this one, 3x. Remember that we already done with the question. This is just for some clarification, or just in case you get another question that is revolving around this. So if you have 3x to power 3 and you want to differentiate, what you usually do is that you usually pick this number, you multiply by this number, such that you will have 3 multiplied by 3, like this. And then once you have 3 multiplied by 3, what you do, you pick this number x the same way it was, and then you put the 3, but now you minus 1, such that you'll have 3 multiplied by 3, that's 9x, and then this one reduces by 2 to get a 2, like that. So that is exactly how you are really supposed to work out that. But the solution for this particular question, yeah, reaches up to this point, like that. So let's get into our question 14. And actually, this seems to be very interesting. We are told that liquid P contains 30% of water, while liquid Q contains 48% of water. And then we are told in what ratio should P and Q be mixed so that the mixture contains 42% of water. So when you get such a question, what are you really supposed to do, and how are you really supposed to work it out? Well, there are two main methods in which you can use to be able to arrive to your final answer or rather solution. But here is the easiest way to go about this. The easiest way to go about this is to realize that we have two liquids, and that is liquid P and liquid Q. So the components that we have is water. I don't really think there is any other components. So we put this in a tabular form. We are told that it is in the form of 30%, and the other one is 48%. Amazing. Let's go ahead. In what ratio should P and Q be mixed so that the mixture contains 42% of water? So we want this one to be 42%. This is the easiest and the most straightforward way to go about this. So what we do is that we check the difference between this and this. What's the difference between 30 and 42? That's definitely 12. Is that so? Yeah, 12%. Because 42 minus 30, that's 1 and 2. So the difference is that. What about this one? 42 and 48. How do we get as the difference between these two figures? Okay, what you are going to get as the difference is 42 minus 48, that's 6%. So if you want to mix these two liquids P and Q such that the ratio will be 12 is to such that the ratio will be 42, you'll find the difference and then you alternate the differences. If this is PQ, what you get here, you alternate. This is 12, then 6. So you alternate. So it will be 6% is to 12%. Remember that 6% represents 6 over 100, and 12% represents 12 over 100. You can multiply by 100. You can multiply by 100 to get rid of the percent, to remain with 6 is to 12. You can divide by 6, to get 1 is to 2. And that is the required solution. So if you mix these mixtures in the ratio of 1 is to 2, then that implies that you should be able to get the final solution as 42%. And that is exactly how you are really supposed to go about that. And actually, this is very true because you see, this one is 30% and this one is 42%. Therefore, to be able to get a higher value, a higher percentage than this one, therefore that implies that this one must have been a higher proportion, which is 2, a higher proportion than this one. So that is exactly how you are really supposed to go about that. So let's go ahead and check out the next question. Amazing. Yeah, I see we've not yet done a question about probability. Therefore, this would be a very good question to practice with on probability. You know that the probability that it is rainy in the morning is 0.6. The probability that John carries an umbrella while going to work is 0.4. Find the probability that it is not rainy and John does not carry an umbrella. How are we really supposed to solve this? So to be able to solve this easily, we are supposed to draw a probability tree so that we can be able to visualize this clearly. So we have that we have two likelihoods. It can be rainy and also it can also be not rainy. So we are told that the probability of being rainy is in the morning is 0.6. Oh, that's quite a huge probability because that implies that more than half of the times it's going to rain. Well, let's work out with what we have. So therefore, if this is 0.6, we do 1 minus 0.6, we get 0.4. Therefore, the probability for not raining is 0.4. Let's go ahead. We are told that the probability that John carries an umbrella while going to work is 0.4. So this is carries an umbrella. Carries. So he can carry, and he can say, I'll not carry. So he can say, I'll carry the umbrella, or he can say, I'll not carry the umbrella. But the probability of carrying an umbrella is 0.4. Therefore implies that the probability of not carrying the umbrella is 0.6. I believe that you know how we got this 0.6. It's because for this tree, it's supposed to add up to 1. Therefore, we have to minus 0.4 from 1 to be able to get the other probability. But for this, we are told that for carrying the umbrella is 0.4. Therefore, for not carrying the umbrella should be 0.6, like that. So let's go ahead. So what's the probability that it is not rainy? It is not rainy. So we are looking at this. It is not rainy. So it is not rainy, and John does not carry an umbrella. Not carry umbrella. Okay, so not rainy. So what we do is that we pick the probability for not raining, which is 0.4, and we multiply that by not carrying the umbrella, which is 0.6. What do we get by this? You can add this, or you can multiply this with your calculator directly, but we know that 6 times 4 is 24. But now we have 2 decimal places, therefore that should be 0.24, like that, and you should be able to get that for that. The second part of it is telling us it is rainy and John carries an umbrella. It is rainy, it is rainy. Therefore you have to find it is rainy and carries umbrella, and carries an umbrella. So rainy, it's 0.6. We multiply by carries an umbrella is 0.4. Again, also this one is going to give us a similar case because it's only the numbers that has interchanged, that is in terms of doing the multiplication, and that's going to give you 0.24, and that is the required solution for that, and that is how you're really supposed to handle that. So let's move on to the final question that is there in section 1. We have it right here with us, and that is x minus 2y. This is so cool and so wonderful, and I believe that you do love working with such numbers like this, where we've got some squares, some linear numbers. Yeah, it's usually something that is a bit interesting, and actually this is the easiest question that you should handle, because you can always be able to confirm whether you got it right or wrong. This is the only question that you can be able to mark for yourself. I'll show you how. So we have x minus 2y is equals to 1. So what we do is that since we have got another equation here where we are having x squared, so we can try to convert this one in a way that we are able to make x the subject of the formula. And the way that we are able to do that is take this negative 2y to the other side to have it as positive 2y plus 1, like that. And then we pick this other value that we have x squared plus y squared is equals to 29. So instead of writing this x, we are going to write 2y plus 1. Therefore, we write 2y plus 1, and then we square that, and then we have plus y squared is equals to 29, like that. For this, we open up the brackets. Remember how we open the brackets? We square what we have here, 2y. We square the whole of this. 2 squared, that is 4, and y squared is y squared. Therefore, we get 4y squared. And then we have plus. We have this other figure, 1. We square that, we get a 1. And then we have got a plus. We multiply everything. We have 2 multiplied by 2y multiplied by 1. 2 by 2y, that's 4y by 1. It doesn't change much, but we have that. So we can put the similar terms together. We have 4y squared plus 4y. Can we pick 29 to the other side? Yeah, we can do that. We have plus 1 minus 29 is equals to 0. We have 4y squared plus 4y minus 28 is equals to 0. Is this number divisible by 4? Yeah, we divide by 4. We divide by 4. How do we get there? We get y squared plus y minus, what do we have here? 28 divided by 4. That is 7. Yeah, but it's always good to ensure that you do really confirm correctly that everything is well set. Remember that we said that we take 2y to the other side to have 2y plus 1, such that we have our initial equation here, x squared plus y squared is equals to 29. We replace x with this value 2y plus 1, 2y plus 1 like that. And then we open the brackets by doing 2y. We square that to have 4y squared. We square the second value, which is 1. And then we multiply everything. 2 times 2, that's 4y, is equals to 29. And then we have 4y squared plus this 4y. And then we have plus 1. And then we pick 29 to the other side to have minus 29. 1 minus 29, that's negative 28. And therefore we have 4y squared, we divide by 4 everywhere. You have y squared plus y minus, this is going to give us negative 7 is equals to 0. Okay. So once we have that, we find the value of y. Can we be able to find the value of y from this? We can use the quadratic formula, which says that the value of y should be negative b plus or minus b squared minus 4ac over 2a. Yeah, let's go ahead and apply this. So that will be equivalent to here. We'll have negative 1 because this is b. And then we have plus or minus square root of b squared. What is b squared? For our case, it is 1. And then we have minus, and then 4ac. 4ac is 4 times this, 4 times this. This is 4 times 7. 4 times negative 7, that's negative 28, like that. And then we have divided by 2. So what we get here is negative 1 plus or minus the square root of 1 plus 1 plus 28. That's going to give you 29. And then divided by 2. I don't know. Mostly, you will not get questions that are going to give you this sort of trouble. Mostly, you'll get questions that will give you a number that is not having square root whose root is quite huge. Mostly, you'll get perfect roots, but it's also good for our practice because the most important thing is to understand how you are really supposed to handle these kinds of questions. Yeah, so we have it like that. So next what we do is that we simplify this. So you get to find the root of 29. So once we get the root of 29, then minus 1 over 2, this one should give you the value of x there. And finally here, the value of y. How are we going to get the value of y? For y here, you are going to make y the, or rather actually this one is giving you remember here, it's this one is going to give you the value for y actually. This one will give you the value for y because this is the value for y that you are finding here. And finally, you have to be able to find the value of x. The value of x, now what you'll do is that you'll use this formula that we have here, and that is 2 into brackets. Now the value for y is this. I don't have a calculator around, that's why I'm not completing this. I don't know if I'll be able to get a calculator right now. So is equals to, so here you see what you're doing here is 2 multiplied by y, and then we have to add 1. This is because we say that x is equivalent to 2y plus 1. So it is equivalent to 2 multiplied by the value of y, which is 1, which is this one, plus 1. So this one should give you the value of y, and this one should be able to give you the value of x. But once you find that, that should be the final answer for that, and you'll have solved that equation as it's really supposed to be solved. And that is exactly how you're really supposed to go about that. Yeah, it's only that I don't have a calculator, but yeah, once I get it, I'll be able to post for you the final answer for that. But that is the required solution. But the most important thing is to understand the procedure that you use and how you get to have the good flow following on. So the first thing that you do is always to have the easiest number being converted to be the subject of the formula, so that from there you can substitute to the other values that we have. For this case, we let the value of x to be the subject of the formula, and then from there we substitute it right here such that we have 2y plus 1 squared, and then from there we are able to form a quadratic equation. And then after forming the quadratic equation, what we now get is to find the value of one unknown, which is y, and then from there we can always get the value of the other using one equation. And that is how you're really supposed to go about that. So that is it for section 1, but I can see that we still have part B. So part B, we'll do it in the next video that is coming up. You can check it in this particular channel for KCSE Mathematics to be able to follow up with that. But also you can also be able to visit our website, that is kcsemathematics.co.ke, to be able to connect with more tutorials, and you can be able to get some practice materials there, and many more things that pertain KCSE Mathematics, where we continue to make mathematics more fun and enjoyable at the same time, making it easier. So until next time, bye bye for now. Yeah, remember to subscribe to this channel and to keep following through the tutorials that we get to post. Bye bye.